Ecosystems are dynamic systems where stability depends on the continuous cycling of matter and flow of energy. Two of the most vital cycles are the carbon cycle and the nitrogen cycle, which ensure the availability of essential elements for life. Today, we'll explore the significance of these cycles and the far-reaching consequences of disrupting them. The carbon cycle is crucial for maintaining the balance of carbon in the atmosphere, oceans, soil, and living organisms. Carbon is a building block of life, forming the backbone of organic molecules like carbohydrates, proteins, and DNA. This cycle begins with plants and other producers, which absorb carbon dioxide from the atmosphere during photosynthesis. They use this carbon to create glucose, storing energy that moves through the food chain when animals consume plants. When organisms respire, carbon is released back into the atmosphere as carbon dioxide. Decomposers, like fungi and bacteria, play a vital role by breaking down dead organisms, returning carbon to the soil and releasing it into the atmosphere. Other processes, like the burning of fossil fuels, volcanic eruptions, and the dissolution of carbon in oceans, also contribute to this cycle. When the carbon cycle is disrupted, the effects ripple across ecosystems. For example, excessive carbon dioxide in the atmosphere from burning fossil fuels contributes to global warming. Higher temperatures affect habitats, disrupt migration patterns, and increase the frequency of extreme weather events, threatening biodiversity and ecosystem stability. Deforestation is another major disruptor. Trees act as carbon sinks, absorbing carbon dioxide during photosynthesis. When forests are removed, not only is less carbon absorbed, but the carbon stored in trees is released into the atmosphere when they decompose or are burned. This double impact accelerates climate change and destabilizes ecosystems. Nitrogen is another essential element, critical for building proteins and nucleic acids like DNA and RNA. However, most nitrogen exists as a gas in the atmosphere, which plants and animals cannot use directly. The nitrogen cycle converts nitrogen into forms usable by living organisms and ensures its continuous availability. The cycle begins with nitrogen fixation, where certain bacteria convert atmospheric nitrogen into ammonia, a form plants can absorb. Plants use this nitrogen to build proteins, which then pass through the food chain as animals consume plants and other animals. Decomposers recycle nitrogen from dead organisms, breaking it down into ammonia, which can re-enter the cycle. Another key process is denitrification, where specialized bacteria convert nitrogen compounds back into nitrogen gas, returning it to the atmosphere and completing the cycle. When the nitrogen cycle is disrupted, ecosystems face significant challenges. One major issue is the overuse of synthetic fertilizers in agriculture. These fertilizers add excessive nitrogen to the soil, and much of it runs off into water bodies. This leads to eutrophication, where algal blooms block sunlight and deplete oxygen as the algae decompose, creating dead zones where aquatic life cannot survive. On land, too much nitrogen can harm plants adapted to low nitrogen environments, reducing biodiversity. Additionally, excess nitrogen in the atmosphere from industrial processes and vehicle emissions contributes to air pollution and acid rain, further impacting ecosystems. The carbon and nitrogen cycles are deeply interconnected. For example, plants use carbon during photosynthesis and rely on nitrogen for growth. Disruptions to one cycle often affect the other. Consider how deforestation not only releases carbon but also reduces the soil's ability to retain nitrogen, weakening the ecosystem's overall stability. Disruptions to these cycles can lead to a cascade of problems. Climate change driven by an imbalance in the carbon cycle affects temperature and precipitation patterns, altering ecosystems worldwide. Coral reefs, for example, suffer from ocean acidification, a result of excess carbon dioxide dissolving into seawater, making it harder for corals to build their skeletons. Similarly, disruptions to the nitrogen cycle reduce the availability of clean water, destroy habitats, and threaten food security. Crops may grow less effectively in over-fertilized or polluted soils, leading to decreased agricultural productivity. Despite these challenges, there are ways to mitigate disruptions and protect these vital cycles. Practices like reforestation, reducing fossil fuel use, and adopting renewable energy sources can help restore balance to the carbon cycle. In agriculture, using organic fertilizers, planting cover crops, and reducing chemical runoff can minimize the impact on the nitrogen cycle. By understanding the importance of these cycles and the consequences of disrupting them, we can make informed decisions to preserve the ecosystems that sustain life on Earth. The carbon and nitrogen cycles are foundational to ecosystem stability, providing the building blocks of life and maintaining balance in nature. When these cycles are disrupted, the effects are felt across the globe, from changing climates to degraded habitats and reduced biodiversity. Protecting these cycles isn't just about saving ecosystems, it's about safeguarding the future of life itself.